Hello everybody, the topic of this section is annuities. In this section, we will study the concepts of annuities and the calculations of its future value and present value. In a savings plan or an investment project, the future cash flows are often the same each year, and in a loan repayment schedule, the payments of each year are also the same. Such a level stream of cash flows or payments is called as annuity. So, annuity is a level stream of cash flows or payments with the same amount in each period. There are two kinds of annuities. If the cash flows start immediately, as in a savings plan or a lease, it is called an immediate annuity. If the cash flows start at the end of the current period rather than immediately, it is called an ordinary annuity. More specific, let's see an example about future value. Suppose that you intend to save $100 each year for the next 3 years. How much will you have accumulated at the end of that time if the interest rate is 10% per year? If you start saving immediately, you deposit $100 at the beginning of the first year, that is, there is a minus 100 at time 0. And then, you save another $100 at the beginning of the second year and third year, corresponding to time 1 and time 3. This cash flow is an immediate annuity. While in the case of an ordinary annuity, the first $100 is deposited at the end of the first year. This timeline contrasts the immediate annuity and ordinary annuity clearly. Although in both cases there are the same number of payments, under the immediate annuity pattern, the entire amount earns interest for an additional year. Like the calculation of future value for multiple cash flows, in the immediate annuity, the FV is equal to the sum of FVs for the 3 cash flows. 100 multiply 1 plus 10% to the third, plus 100 multiply 1 plus 10% to the second, and plus 100 multiply 1 plus 10% to the first. Factoring out the constant annual cash flows of $100, the FV is equal to 100 multiply the sum of 3 future value factors from the first to the third. While in the ordinary annuity, the FV is equal to 100 multiply the sum of 3 future value factors from the 0 to the second. Generally, define the constant annual cash flow as A, interest rate as I per year, and the number of years as N. The FV for this immediate annuity is equal to A multiply the sum of future value factors from the first to the nth. In further, by the algebra argument, the FV is equal to A multiply 1 plus I to the n plus 1 minus 1 altogether divided by I and then minus 1. For the ordinary annuity, the FV is equal to A multiply the sum of future value factors from the 0 to n minus 1. In further, is equal to A multiply 1 plus I to the nth minus 1 altogether divided by I. Therefore, an immediate annuity would have an FV equal to that of the ordinary annuity multiplied by 1 plus I. If there is no particular notation, we usually regard an annuity as ordinary annuity. Often we prefer to compute the present value rather than the future value of an annuity stream. For example, how much would you have to put into a fund earning an interest rate of 10% per year to be able to take out $100 per year from the next 3 years? The answer is the present value of the 3 cash flows. So the present value of the annuity is the sum of the present values of each of the 3 payments of $100. That is 100 over 1 plus 10 to the first, plus 100 over 1 plus 10% to the second, and plus 100 over 1 plus 10% to the third. In general, the formula for the present value of an ordinary annuity with constant annual cash flow A for n period at an interest rate of I is A over 1 plus I to the first plus 2A over 1 plus I to the nth, which is equivalent to A multiply 1 minus 1 plus I to the minus nth altogether divided by I. In further, let's see an example about buying an annuity. Suppose that you are 65 years old and are considering whether it pays to buy an annuity from an insurance company for a cost of $10,000. The insurance company will pay you $1,000 per year for the rest of your life. If you can earn 8% per year on your money in a bank account and expect to live until age 80, is it worth buying the annuity? Among the rows studied in the section Alternative Discounted Cash Flow Decision rows, there are 3 rows can help us make the investment decision about this annuity. The first one is NPV row, which is the most direct way to make this investment decision. There is no particular notation for this annuity, so we take it as an ordinary annuity. Then it is expected to make 15 payments of $1,000 each year, starting at age 66 and ending at age 80. By the formula of PV for the ordinary annuity, the PV of these 15 payments at a discount rate of 8% per year is $8,559.48. And the NPV is equal to this PV minus the cost, $10,000. Finally, we get that the NPV is negative, so this annuity is not worth buying. The second row is IRR row, where we should compute the implied interest rate on the annuity. Take the PV as $10,000. The constant annual cash flow is $1,000, and the number of years is 15. The IRR is obtained as 5.56% per year, which is smaller than the interest rate of the bank account, 8%. So it is not better to invest in this annuity. The next row is the payback row. We need to find the number of years. Take the PV as $10,000, the constant annual cash flow as $1,000, and the interest rate as 8%. By the formula of PV for the ordinary annuity, the N is obtained as 21 years. So compared to the bank account, if you live for 21 years rather than 12, the insurance company would end up paying you an implied interest rate of 8% per year. In conclusion, the investment for the insurance is not worthwhile. Another example is about taking a mortgage loan. Suppose that you have just decided to buy a house and need to borrow $100,000. One bank offers you a mortgage loan. It's to be repaid over 30 years in 360 monthly payments. If the interest rate is 12% per year, what's the amount of the monthly payment? The monthly payment on the 30-year mortgage should be computed by using a monthly period, that is, N is 360 months, and a monthly interest rate of 1%. By the formula of PV for the ordinary annuity, PV is $100,000, I is 1%, and N is 360. Solving this equation, we can get that the monthly payment A is $1,028.61. However, another bank offers you a 15-year mortgage loan with a monthly payment of $1,100. Which loan is the better deal? It might seem as if the 30-year mortgage is a better deal because the monthly payment is less than $1,100 for the 15-year mortgage. But the 15-year mortgage is finished after only 180 payments, whereas the 30-year mortgage is finished after 361. Here, the interest rate will be a better measure. Again, by the formula of PV for the ordinary annuity, PV is $100,000. A is $1,100. N is 180. The monthly IRR I is obtained as 0.8677%, or an annual percentage rate of 10.4%. It's smaller than 12%. This means we can pay the loan with a lower interest rate. So the 15-year mortgage is a better deal. In summary, we have studied what's annuity and the calculations of FV and PV for it. Two examples about buying an annuity and taking a mortgage loan are also discussed. That's all about this section. Bye.